Okay, so for the 8A notes, the big idea is not to divide by zero. So when we have a rational function, you're going to have division, and so you have a possibility where you might end up dividing by zero. So that's why we need to look at the domain. We are not allowed to divide by zero, and that means that the denominator cannot equal zero. So we're going to actually set the denominator not equal to zero when we are looking at the domain of a rational function. So I'm going to start with, for example, x plus 4 cannot equal zero. And then I can just solve it like it is an equation, except it's a non-equation. So I know that x cannot equal -4. So now when I write this as a domain, I'm going to say that my domain is x such that x is not equal to -4. So while I could write the domain in interval notation, that gets really annoying because I want to be able to write it simply. So if I wrote it in interval notation, it would be everything in the real numbers except for -4. So that would be from -infinity to -4, and then from -4 to infinity with all round brackets. So this one is better. So set notation is better for my domain. Okay, so I'm not gonna, for number 2, I'm not gonna simplify anything because it is important to know that the original function has all of these factors. We will talk about what to do to simplify in a few minutes. But first, we're just gonna start with setting each factor not equal to 0. So then when I write my domain, I can say that my domain is the set of x's such that x is not equal to -1 or 3. So that's how I will write my domain. For this last one, x squared plus 1 cannot equal 0. So when I go to solve that, x squared cannot equal -1. Well, x squared cannot equal -1 anyway. This is true over the real numbers. X squared does not equal -1 because we need imaginaries for that to be true. So my domain is x such that x is an element of the real numbers. Or you could write the domain as all of the real numbers from -infinity to +infinity. Any of those, either of those work as your domain. But if I do have a number that x cannot be equal to, or a couple of numbers x cannot be equal to, it's easier to write it in set notation versus interval notation. Okay, so let's look at the next problem. And that is, now we're talking about vertical asymptotes and holes. We're going to do that in the next video.